Hello and welcome to Database Management System. I am Parinda Prajapati and today we are going to start the other topic of this particular unit 4, which is relational database design. So next topic in this chapter is normalization. So what is normalization? Normalization is the process of organizing data in the database. So what is the need of normalization? So what we want to do is, suppose we have database, then if you don't know the normalization, then what you will do is you will simply make table and you will randomly add the data in that particular table. But that tables lead to some errors or some more space, more memory occupancy. So in that case, the need of normalization is to remove the redundant data and minimize disk space and reduce chance of data errors. And there are different type of normalization. Here we have first normalization, second, third BCNF, fourth normal form, and fifth normal form. So what are these normal form? So for that, here we have one table where we have normal form with description. So if you have one table, then what you have to do, you have to start with first normal form and you have to convert or decompose your table up to fifth normal form. And these are the rules of particular normal form. But we will check these rules later on. Let's first see the each normal form in detail, and after that we will come back to this particular table to summarize all normal forms. So let's start with first normal form. Here first normal form, we have one condition that it contains atomic value. So what do you mean by atomic value? Atomic value, which means attribute must hold single value. So now we already know that some attributes may have multi-valued attributes, like phone number or the courses some students have adopted. Like suppose let's take an example of phone number. So suppose particular person, particular student can have more than one phone number. So if I am making one table like SID and phone number, and in that particular phone number field or column, you are with SID 1, you are giving more than one phone numbers in particular one cell. It is not the atomic value, because you are giving the multiple value of that particular attribute. Then you can say that that table is not in first normal form. Here we have example employee ID and employee phone. So here first employee have two phone numbers, second have one, and third have again two numbers. So if I'm writing data like this, then this table is not in the first normal form. So to convert this table in the first normal form, what I have to do is I have to specifically provide the condition that my each and every attribute must have atomic value. So to convert this table into first normal form, what I have to do is, let's decompose this like this. So employee ID and employee phone. So now to provide the single value, what I'm doing is I'm giving employee ID 1 with first phone number, then again employee ID 1 with the second phone number, then 2 with his phone number, and then again 2 times 3, because 3 also have two different numbers. So to fulfill this condition of atomic value, I am converting this table into this table. So this is how we can say that now this table is in first normal form. So now let's check the second normal form. What is second normal form? The first condition of this normal form is relation must be in 1NF. That means relation must contain atomic value only. So here as we have converted this relation into first normal form, so whenever you are going one normal form ahead, each and every time the first condition will be that you must satisfy the previous normal form condition. So here also we are having first condition that the relation must be in first normal form. That means it must have atomic value. And second condition, that all non-key attributes are fully functional dependent on the primary key. Now what is non-key attribute? So let's take an example that here we have in table for faculty ID, subject, and faculty age. So now we can say that here faculty ID is the primary key, and subject and faculty age, that are non-key attributes, because we can't make these attributes the key attributes. We can't say that subject is the primary key or age can be primary key. No, they can't be. So in this table we have a faculty ID, subject, and faculty age. So here suppose I have candidate key, faculty ID, and subject. Then if I'm giving the dependency like FID and subject determines F age, in that case my faculty age is just depend on faculty ID only. To determine the faculty age, I don't need subject. So in that case, for the FID, subject determines F age. This dependency, this is not the full functional dependency, this partial dependency. So in that case, if I want full functional dependency for this table, in that case what I have to do is I have to decompose this table. So now I will decompose this table into faculty ID subject and faculty ID age. So now I can say that in FID and F age, in second table I have non-key attribute F age, which is completely or fully dependent on the FID. So I just remove the subject and just make two table from this single table. So this how we are getting the second normal form. After that, the third normal form. So first condition will be that relation must be in second normal form. And for the third normal form, another condition is it should not contain any transitive dependency. Now, what is this transitive dependency? We already know that A determines B determines C, and A determines C. This is known as partial dependency. So, transitive dependency. So let's take an example that we have SID, SNAME, SZIP, that means zip code, and SCT. So here we can say that we have dependency that if I'm taking SID as a key attribute, then SNAME is completely dependent on the SID, and SZIP is also dependent on the SID. But to determine CT, I don't need SID. If I have just a zip code, then I can directly determine CT. So here, what the functional dependency we will get? We will get that SID determines zip code determines CT. So this how we will determine SID determines CT. So this will be transitive dependency. And in third NF, we have to remove transitive dependency. So to remove transitive dependency, I need to decompose this table. So let's decompose this table. So I'm making first table student detail, where I am taking three attributes SID, SNAME, and SZIP. In that, I am not getting any transitive dependency between these three attributes. And now I'm separating zip code table with SZIP and SCT. So here CT will determine by zip code. So this is how I'm removing transitive dependency from this particular table. So what you have to do is on each and every time to remove some dependency, you have to decompose your table. Okay, so this is now we can say that these two tables, student details and zip codes, are in third NF, because in both table, whatever the attributes we are having, are not having any transitive dependency. Then after we have boys code normal form. What is BC? In BCNF, if we have X determines Y dependency, then that is a condition that X is a super key of the table, must be the super key of table. Relation should be in third NF, that is the first condition. And for every functional dependency, LHS, that means left hand side, is super key. So as I said that X determines Y, then X must be super key. So let's consider the last example. So in last example, we had student details and zip codes. We already decomposed this table, determine the third NF, and now we are getting these two tables. So in these two tables, let's check that which attribute is the key attribute. So here we have SID is a key attribute, and here we have zip code is a key attribute. So in both the table, we are getting the dependency like this. You can see here that SID is the super key in the relation student details, and SZIP is the super key in the relation zip codes. So we are getting SID determines SNAME and SZIP. As you can see that using SID, I can determine SNAME also and SZIP also. So I can write that SID determines SNAME, SZIP. So in this functional dependency, this is a functional dependency of our relation student details. In that case, our LHS, which is SID, is super key. Yes, of course, SID is a super key. And we have another table. In that, we are getting dependency like this. SZIP determines SCT. So in that case also, we have ZIP, which is also super key. So we can say that these both confirms LHS is super key, so that we can say that these both are in BCNF. Then after I have fourth normal form. What is fourth normal form? So relation will be in 4NF if it is in voice code normal form, because that is the previous normal form and has no multi-valued dependency. Now what is multi-valued dependency? So for a dependency A determines B, if for a single value of A, we are getting multiple B value, then relation will be in multi-valued dependency. Let's take an example. Get more clearance. We have SID, course, and hobby. Now just to check that what kind of data we are having. We are having two SID, one, okay, the same SID, like first we have one, the course is science and hobby is cricket. And again, I'm writing one because that student has taken another course also, and he has another hobby also, which is hockey. Then I have second student who has taken two courses again, C# and PHP, and he also has two different hobby, cricket and hockey. Now, if I want to join this table, and while doing the join, what I have to do is I have to still simplify this relation like that. What I will get is SID, course, and hobby. But what I will do, one science, cricket, then again one science, hockey. Then I will get one maths, cricket, then one maths, hockey. Then I will get two C# cricket, two C# hockey. And then I will get two PHP cricket, two PHP hockey. So in that, we can determine that for particular A determines B, like SID determines course and SID determines hobby. The course and hobby are completely not relevant to each other. In that case, we are getting multiple values for B, or just single one, we are getting multiple values of B. So this is known as a multi-valued dependency. So to remove multi-valued dependency, we have to decompose this table. So what I will do, I will simply decompose these two attributes. So let's can result like here I'm dividing this table into SID course and SID hobby. So this how I'm removing multi-value dependency in this particular table. So now I will get SID course and SID hobby. And now last one is fifth normal form. What is fifth normal form? So relation must be in fourth normal form and not contain any joint dependency. That means if you are decomposing your table, after decomposing, whatever the new table you will get, suppose your relation R it is decomposed into R1 and R2. Whenever you are joining this R1 and R2 relation, after joining, whatever the result you will get, it must be the same as original relation R. That is known as lossless join. So let's take an example. Suppose we have one table ACP where we are having agent, company, and product. We have different agent A1 and A2, and different companies they are working for and different products they are having. So if I'm decomposing this table, because we can say that we can see that here we are having multi-value dependency. For A1, we are getting multiple records for A1, first, second, third, and fourth, and due to company and product, and which are again irrelevant to each other. So we can separate these two attributes. So remove multi-value dependency, I'm getting three tables. In first table, I'm getting agent and product, where particular agent has particular product. So here, particular agent 1 is having two products, and A2 is having one product. Then in table R2, I'm giving agent and company. So agent 1 company is PQR. Again, agent 1 has another company XYZ, and agent 2 has PQR. So now to join these two, I need to map company and product also. So this company has this product also. This company PQR has bold product also. XYZ company has nut also, and XYZ company has bold. So this how I am dividing or decomposing my original table into three different table. And while if I join these three table using join query, normal join query, at that time it is must that I should get same result like this. So for that you can read this second paragraph. The relation decomposed into two relation must have lossless join property, which ensures that no extra tuples are generated when relations are reunited through a natural join. So if suppose I'm joining this three table, and if I'm getting some extra tuples or extra records from this, then we can say that that relation is not in fifth normal form. But suppose after joining using natural join, I'm getting the same relation like this, then I can say that that relation is in fifth normal form. So in all normal form, what we are doing is we are just decomposing the table. But in last normal form, we are checking that after decomposing, if we rejoin those tables, then we should get the same table like the original table. So this is fifth normal form. So now let's get back to that particular table which I talked about. So here this is the summary that in first normal form, what we have to check, we have to just check that each attribute must contain atomic value, like multiple phone number, multiple courses, multiple hobbies in one single cell is not allowed. In second normal form, we have to check that it must be in first normal form, and all non-key attributes are fully functionally dependent on the primary key, not partial dependency. There should not be any partial dependency in this second normal form. In normal form, we have to check that there should not be any transitive dependency. A determines B, B determines C, then A determines C. This kind of dependency should not be there. In fourth normal form, we have to remove multi-valued dependency. And in fifth normal form, we have to check that after decomposing, if we are rejoining those tables, then it must be lossless. So this is all about normalization. Thank you so much. And we'll see you in the next lecture.